Good afternoon, everybody. Thank you for joining us for this special conversation, which is part of the Henry Ford Conversations series. My name is Jessica Robinson, and I have a very special role with the Henry Ford, and that is one of the entrepreneurs in residence. And my focus is on mobility, power, and energy. And so what I get to do with the museum is help the organization think about taking its collection to different audiences and to different places than it's been before. And so this discussion is part of a conversation we wanted to bring to our joint group and membership today, which is focused on 100 years of electric vehicle engineering. And so I have with me today two participants. The first is Mark he's the president of DG Technologies, and Mark is also the incoming chair of the SAE Detroit section. And we also have with us Matt Anderson, who's the curator of transportation at the Henry Ford. And so I mentioned this is part of the Conversations series, and the Henry Ford Conversations is a virtual series featuring leaders like us in our fields who are discussing topics and trends relevant to the world that we live in today. And these sessions are hosted and curated in partnership with the Henry Ford's experts and held digitally, like so many things are today, here on Zoom. And so this is part of We Are Innovation Nation, the virtual learning series, which you can find out more about at thehenryford.org. And so I mentioned there's a couple organizations here today, and I mentioned my role with the Henry Ford. So I thought I'd start by telling you a little bit about my background, and then we'll jump into the conversation here. So I am co-founder of a number of organizations here in the Detroit area, all focused on mobility. But most specifically and relevant to this discussion today are two. The first is the Michigan Mobility Institute, which is a nonprofit that focuses on accelerating mobility workforce development, specifically around upskilling, training programs, and post-secondary degrees. And we do that by bringing industry and education partners together. So we're really, again, focused on the people side of the future of this industry. And I'm also a co-founder and partner at Assembly Ventures, which focuses on investing in and strategically supporting entrepreneurs who are building the future of movement. So I promised you it was all about mobility, and that's definitely true for my background as well. And so today, what we really want to explore is what we can learn by bringing together two very deep subject matter experts from maybe perhaps different areas of this conversation. And both Mark and Matt are experts in their own right and share a deep passion for something that probably many of us here on the Zoom today do, which is the automobile and the design of the automobile. And I'm pretty sure, based on the conversation we had before we jumped on with you, that we'll see by the end that there's a lot in common and a lot that we can actually learn from one another. And so I'm pretty sure they'll be able to give you a better handle on their own backgrounds and experience than I could do justice to on my own. So Mark, let's start with you. Can you tell us a little bit more about your background, your current work at DG Technologies and the SAE Detroit section?
Absolutely. Good afternoon, everyone. Mark Zachos speaking here. And you know, SAE used to stand for Society of Automotive Engineers. SAE back over 100 years ago was started by some folks that included Henry Ford. Today, there's about 130,000 members worldwide, so it's a worldwide organization. And I have the opportunity as a volunteer to work in many places within that organization. One is to help develop technical standards, contribute my engineering background. I went to the University of Michigan, engineering, computer and electrical engineering, to standards for heavy duty and light duty vehicles. My day job, that's kind of how I pay my bills, is I too have a startup, but that's been over 30 years ago. I started in my basement. And in Dearborn, that's where my heart is really, and not too far from the Henry Ford that startup, we moved to Farmington Hills, where we're at right now, and we work on diagnostics, vehicle diagnostics, and electronics, and cybersecurity is a big area of focus for my business too.
Great, Mark, thank you so much. And Matt, can you tell us a little bit more about your work at the Henry Ford?
Yes, so I'm curator of transportation. So I work on developing, caring for, and interpreting the museum's mobility collections. So automobiles, railroad equipment, and airplanes in our case. And my own background, I've been in the museum field for many years now, and worked at railroad museums. I've worked at automotive museums, worked at a state historical society. But the real pleasure of working for the Henry Ford is that I get to combine all of those loves, every form of transportation that we have. But of course, automobiles are one of our real strengths, and that's the collection I tend to spend most of my time with and have particularly enjoyed working with.
Thanks so much. I mentioned that we're here today to talk about electric vehicles, and so I think we should get started on that track. And let's start with, I think, what most people, at least consumers today, people I know, think about when they think about electric vehicles, and they think of Tesla. And they imagine electric vehicles as a fairly recent innovation. And Matt, when we first met through this residency, I asked you what really seems now like a dumb and simple question, which is, what does the Henry Ford have in its collection for electric vehicles? And I see you're virtually there today by the magic of Zoom. And so, one of the things I learned from you is that this history is actually fairly extensive. And I think for a lot of people, even engineers in this industry, they might be surprised just how far back these vehicles go. So for those of you joining, we have some digital artifacts with us today that we're going to use as a prompt here. But Matt, can you tell us a little bit about the history of electric vehicles?
Yeah, I'd be glad to. We're fortunate at the Henry Ford to have an extensive collection of not just automobiles, but particularly early automobiles. And we have not one, but two, believe it or not, pre-1900s, so 19th century electric vehicles in our collection. And they are both what I would call prototypes, experimental vehicles, certainly not production cars in any way, shape, or form. But the first one, which you see the photo of right here, is our Edison electric runabout, initially built circa 1889. And Edison, in this case, is Thomas Edison. And he had no intention of going into business producing automobiles, but wanted to build the car as sort of a test platform for batteries. He was working on developing better electric batteries with longer range, quicker recharge, that sort of thing, and put this car together as a part of that test. And as you look at it, it's a three-wheel vehicle. It actually has two electric motors, one connected independently to each of those two front wheels, which I suppose would eliminate the need for a differential on the axle. And then, of course, the one wheel in the back, which is your steering wheel in this case, so it would work like a backward tricycle. And the driver controls, you'll notice, are up on the driver's seat there on the right-hand side. And no steering wheel. It would be a tiller and a lever for controlling your throttle position, your speed. And Edison played with this for a little bit in the late 1880s, early 1890s, then kind of put it away on the shelf for a while until he got back involved in battery development with his good friend Henry Ford in the 19-teens, and he pulled this vehicle back out to do some additional tests on electric vehicles. But it's a special piece in our collection, and I should mention Henry Ford, of course, really worshipped Thomas Edison. There's no other way to put it. So this would have been one of many pieces that Ford collected to document his friend, up to and including the Menlo Park Laboratory, famously in Greenfield Village. We have another pre-1900 vehicle too here we're looking at. This is another tricycle, interestingly enough. This one built by a fellow named Andrew Riker, and built a little later, 1896. And the setup of the design on this vehicle is a little bit different. You do see the three wheels again, but in this case, you'd steer with the front wheels, and your motor is attached to the rear wheels, which again simplifies the drivetrain with no need for a differential. And the motor's right there on the hub. The batteries themselves are stored underneath the driver's seat. And in this case, the driver controls are over on the left-hand side. And again, a tiller to steer and then a lever to adjust the speed positions. And this would have had 20 cells, 20 different battery cells to power it. And horsepower would have been somewhere around 1. So not a particularly fast or powerful vehicle. But Riker, again, just built this as an experimental car. He had no intentions of going into production. He did achieved some milestones with electric vehicles. In fact, built an electric race car that he set some land speed records with for electric power. But he's a classic story of someone who kind of saw the writing on the wall. He realized that gasoline was going to be the fuel of the future, that electricity wasn't going to be around much longer. So he actually stopped his work on electric vehicles, took a job with Locomobile, who just built gasoline-fueled automobiles. And I should mention, Mark already said that Henry Ford was one of the first members of the SAE. Andrew Riker was actually the first president of the SAE. So he's got definitely some contributions to the automotive industry that continue to be influential today.
That's great. Thanks. And Mark, maybe you can talk more about that. We discovered this coincidence and connection between Andrew Riker and the Henry Ford. And I think in some ways it's not a coincidence at all. I think it speaks to the deep connection between some of the early pioneers in this industry. So who was Andrew Riker and why was SAE formed even in the first place?
There were a lot of collaboration going on in the early automotive days. And actually some of the work that these guys are collaborating together were in standards. So where we have different size lug nuts and we have different size connectors and fasteners, they wanted to try to standardize on components as they were buying a lot from vendors. And give them standard specifications to build their components to. Another thing that SAE did, though, is to bring together people with like minds and interests, and that continues today. In fact, the SAE Detroit event has a lot of commonalities with the early days of SAE and the events that we're putting on here locally, bring together and learn from each other, both in the technical sense and kind of a social sense too. We can't do that today in our COVID world, but we love to, us engineers, we love to get together and shoot the breeze about fasteners or electronic components, believe it or not. It's kind of boring about that sort of thing maybe, but we love doing that on a social as well as a technical sense. So Henry Ford, Riker, and even Thomas Edison and all the other famous names you might hear of have been part of the early history of SAE.
Of SAE, yeah, the Wright brothers too, which again,
Right. So another interesting point I'll bring up real quick is that SAE, we changed the name from Society of Automotive Engineers to just SAE to recognize that SAE also has a very large membership base of aerospace engineers, automotive engineers for cars, trucks, and aerospace engineers as well. So things that go fast in the ground, on the ground and in the air, we're all involved in that in SAE.
That's great. Yeah, and one of the things on the point of partnership and collaboration, the idea of bringing people together is the Michigan Mobility Institute and the SAE Detroit section are also partners. And some of the areas that we really hoped to focus on were building awareness of many of the careers that people actually have today. And Mark, you talked about kind of the evolution of engineering. We have this idea of the mobility engineer of the future. And so maybe we can get you to change your name yet further still to recognize that. But we're also really focused particularly for early and mid-career folks to continue to support people throughout their journeys. And I think again, what better way?
Yeah, the Detroit section, I should like to mention, also offers scholarships. So you can go to our SAE Detroit website, and we really, really want to promote the opportunities for young people that want to get into a technical career. SAE does really encourage that, and we've got a strong support network within our section for scholarships and STEM education.
Absolutely, yeah. So as folks are listening to this conversation, maybe just jumping in as you're transitioning from different meetings, I want to remind everybody that we do have the Q&A section open. So if you have a burning question about the history of electric vehicles or a particular SAE standard that you really are curious to dig into, we've got the experts to do that. So please do make use of Q&A. Don't know that we'll be able to get to everything, but it's again a chance for any of you all to participate in this discussion today. And so as I'm out about in the world, one of the questions that I get asked all of the time related to electric vehicles is range. We talk about range in the sense of how far can these vehicles go on one charge. We talk about range anxiety in consumer adoption today of, am I confident that if I purchase or use an electric vehicle, it will actually get me to where I need reliably? Am I going to break down? And so a question I want to throw out to both of you here is, what's changed over time? And maybe what are some of the design considerations that engineers have actually had to deal with as it relates to batteries? And I'll throw it out to Mark, Matt, both of you to jump in on this one.
I'll just jump in first to say that that range anxiety is nothing new. That was an issue with the original electric vehicles at the turn of the 20th century. And depending on which literature you read or which manufacturers you were investigating, they would advertise a top range of anywhere from 60 to 70 miles, but particularly that involves a lot of downhill driving with a breeze at your back, I suppose. I think in reality, the range probably would have been closer to 35 or 40 miles between charges. But, it was an open question for the first 10 or 15 years of American automobile development, whether we would be using electric, gas, or steam automobiles. We shouldn't forget those either. And they all had their advantages and they all had their disadvantages. But electricity in particular was well suited to urban environments. It was clean, it was quiet, it was much easier to drive the vehicles. You're flipping a switch and moving levers. There's no gears to shift. You're not getting out and crank starting the engine as you would with the early gasoline powered engines. The problem was once you got out of the city, electricity became hard to find. In rural areas, they may not have been electrified until well into the 1930s. So that was sort of a major nail in the coffin, if you will, of electric technology. And then when the electric starter is introduced by Cadillac in 1912, and now you can just flip a switch and the motor starts your gasoline engine, that really is what started the downfall of the first wave of electric cars.
Well, I think, Jessica, one of the things, of course, your question leads to is weight. So weight of a vehicle is directly proportional to the range, right? So how much energy you can store and how much you can push around. And the chemistry of those batteries have been improving throughout recent times. So now we have the lithium-ion batteries. They're a little more difficult from a technical perspective to manage that charge, and how do you charge and discharge them to optimize the amount of energy they retain. And there's electronics. Before, you just connected the plus and minus, and then hook those wires up to the motor, and away you went. But today it goes through a battery, goes through the electronic system that manages the charge, the discharging, the heat dissipation, and the driver demand, and allows for many other complicated control strategies, of course, that you never had in the past.
That's great, thanks. Mark, there's a question we have in the chat around kind of promising next generation battery technology around density, range, and maybe even charging time. Is there anything more that you want to add on that topic?
Well, charging time is also related to how you charge it. So the connections to the off-board charger. You use inductive charging or conductive charging systems. What's the standard for that? Do you have a connector that plugs in the quarter panel on your car and hooks it up to the off-board charger? Do you drive the vehicle over a pad and have inductive charging as you move along. Of course, you don't want you to have your cat out there wandering in between the car and the charging pad, but so there's some safety issues that we have to recognize. We want to have all the cars, you know, be in common. You mentioned Tesla, which is a great company, a great vehicle that they have, but they have a unique charging system that they developed themselves that optimizes the connectors, optimizes the way that the energy is drawn from the grid into the battery system. It's not a standard. Other car companies, other vehicle manufacturers don't do it that way. So if you buy a Tesla and have a charger, you can't, you know, move that charging system onto another brand vehicle. So that's something that SA helps with all the time, is trying to come up with technical standards to that.
The cross-platform standards, yeah. And I would add two things in this subject. One is I'm seeing a lot of startups now think about battery management, and in particular when you have multiple batteries together, managing the state and flow of each of them, so you're not constantly draining one of the cells or one of the batteries, and, you know, doing more smart management there. And then just the other, you know, kind of consistent pursuit around range, and making sure, you know, that people start to feel confident and actually understand how far their trips are, and what they really need for a range perspective. And, you know, maybe Matt, that actually leads into something I wanted to ask you about, kind of picking up on this subject of range and charging, which is, you know, the vehicle evolves, the infrastructure around it has to evolve as well. And we think about, you know, again, various automakers building out charging networks in the modern day. But it turns out that charging technology, right, and has had to evolve with this. So, you know, what do we know about kind of the history of charging technology? And there is a question here about, you know, one of those early EV owners, Mrs. Ford. Where did she have to recharge her vehicle in the Dearborn to Detroit and back trip? Could she make it round trip?
No, that's a great question. And yeah, one of the more unusual vehicles we have in our collection is the Detroit Electric that was owned and driven by Clara Ford. You'd think she'd be driving a Ford or a Model T, but no. She was an electric vehicle, as well-to-do women often were in those days. They were particularly targeted toward well-to-do women as customers. But Clara, I suspect, could have made it back and forth to Detroit a couple of times on a single charge, at about 10 miles back and forth. So shouldn't have been an issue, but she would have had a charger set up there in the garage at Fairlane, and anybody who's visited the Fairlane estate knows that it was a pretty nice garage, so it would have been well equipped. But you mentioned charging technology, and I should point out that we have in addition to Clara's 1914 Detroit Electric, we have a 1922 Detroit Electric, which we keep in operating condition. And if you've been to some of our special events like Old Car Festival, you may have seen this vehicle operate. And this is the charger that was provided with it in 1922. And we still use that charger today to power up the vehicle. Now we use modern batteries, so we've updated those, but it just plugs into the wall, and you plug it in overnight, and there you go. And the batteries, you know, all charged together as a series. So it works. But you're right. This issue of safety with chargers was a concern of some drivers early on. And I would point out that early gasoline automobiles were attacked as being less safe than electric cars, if that makes sense. The electric companies were fond of describing electric or gasoline-powered cars as cars with explosions taking place under the hood or under the driver's seat, right? Because you have all of these little explosions as part of the combustion cycle in the gasoline-powered engine. You don't have that in the electric vehicle. And you just pulled up this catalog here from a Roush and Lang electric car, which I love here. It shows the car being charged in the garage, and you'll notice the person doing the charging is not the mother, it's a little girl, which is to sort of emphasize the fact that this is perfectly safe. No harm will come to her. So yes, that was something that they pushed on in their ads.
If I could also offer some thoughts to charging, in that we always think about electric vehicles here, and then the next one, of course, is the EV1. We could talk about charging and the connection to the grid, and then why in these times people weren't interested in the air pollution, the air quality. You know, that wasn't an issue back then. Today, of course, it is. And we want to make sure they're both safe, the vehicles are safe and clean. One thing that that we need to make sure is that there's a good way to, safe way to make the connection, standard way to make a connection to the vehicle. And how do you measure cleanness of electric vehicle anyway? Is there some sort of, well, it's electric power and the batteries are, you know, you're not polluting, you're not giving off CO2, or are you? I mean, that's something I think we need to talk about in more detail, is how much power actually drawing from the grid. There's got to be a power plant somewhere. Maybe it's in Nevada and not in California. That's burning coal, that's charging those vehicles. All of that is connected to the air mandate, clean air mandate that we see coming out of the state of California. They really led the way in the early days for air quality. And that EV1, I think you had that queued up there. Why don't you go ahead and show that, Jessica? That might be worth to carry the conversation into that one now.
Oh. There she is.
Yeah, Matt, that's one of your favorites. I can't believe it. Are you going to let me drive that next time I'm going to go up over there or what?
I wish I could. It's one of my favorites too. That's as good as electric cars got in the 20th century, and it is, you know, it's kind of occupies the halfway step between a research program and an actual consumer product. GM did put these cars in the hands of the public, but you couldn't buy one outright. You had to lease it from the company, and the company had the right to take it back from you. And that's just what happened after a period of time. GM just determined they couldn't make money building these electric cars, so they took them back and scrapped most of them. But we were fortunate to get one of the survivors there.
Yeah, and what I think is fascinating, again, we had a couple questions about where the EV1 fits in this narrative of electrification in America, a focus on clean air standards. And, you know, Matt, I think you mentioned there's only a couple of these EV1s kind of left, and that's part of the story, right, is they were bought back. And, you know, the technology was, you know, largely put on hold for a great long while.
No, that's right. And yeah, the EV1 sort of used every trick in the proverbial book to increase its range in driving. And as we look at the photo there, you know, Mark mentioned the weight of the batteries is an issue, and the location of the batteries, frankly, is an issue. So they've got them kind of crammed everywhere they possibly can, running along the frame there, along the T in the center, and then along the rear axle. And then the electric motor is up front under the hood. If you look back at that photo of the body of the car, you'll notice how absolutely almost perfectly aerodynamic it is. And you know, that's down, of course, the round shape on the front and the low profile, but right down to the fairings over the rear wheels, you know, to try and reduce air resistance as much as possible. The owner's manual has very specific instructions about the inflation for the tires, the PSI you're supposed to use. You want those tires as full as possible. The fuller they are, the less tread is in contact with the road, so the less rolling resistance you have. So they really did do the best they could. And of course, they would encourage you not to use the heater unless you had to, and you know, even the radio if you wanted to go for the real hyper mileage. I'd point out too that it had a Mark referred to this, but it's an inductive charger on the EV1, so it's just a paddle. It isn't a prong like a traditional plug-in outlet. There we go. So it's perfectly safe. You could even, you know, quote unquote, plug it in the rain or the snow without any risk of shock. So pretty clever engineering.
This is not an SAE standard connector, by the way. I just wanted to point that out to you. SAE is working on has standards for electric vehicle chargers. They've had these for years. In fact, going back even before electric vehicles, you know, had been developed, SAE was working on those standards for testing diagnostics and emission systems, something called OBD2. Plugging something into the under the dashboard of the car, a diagnostic tool There's some standard messages that the tool asks the car, hey, are you polluting, or is everything okay? How are you operating? So to help the mechanic figure out what's wrong with the vehicle and get it back on the road and running in top condition again. Even electric vehicles today, though, have those diagnostic ports on it. They do it something a little differently. Maybe they don't have a physical connection. Maybe they do it by Wi-Fi. You just walk up to it with your smartphone, connect to the vehicle through a wireless link and say, hey, what's wrong with you? And, get some trouble codes and figure out, go from there, how to fix the vehicle. We're working on standards to do that in SAE, but we have to be super careful and not just the security of getting shocked. If you plug in a high voltage, we have to be super careful. Also, something called cyber secure, where the hackers might also connect up to your car. You didn't have that problem back then, did you?
No, you did not to the same way that we do today. Yeah, no, lots of considerations, both the past and the present, in terms of safety and the evolving definition of safety too. I do want to pause for a second, thank everyone for asking your questions. We're trying to queue them up as many as we can. But Matt, maybe for you, a couple of folks were asking, hey, can we show this picture or that picture again? We tried to do that, but Henry Ford has really invested in bringing its collection to the internet in a digital form. Can you talk more about how people find these photos? And also, there was a question about a book on the history of EVs. I'm curious if you or Mark know of one. So resources, where can we find out more with these particular vehicles and things we're talking about today?
Yes, I'm glad you mentioned our digital collections portal. We are working to digitize as many of our artifacts as we can, and of course, starting with the big things like the automobiles. So if you go to our webpage, thehenryford.org/collections, it'll take you to our front door, and you can search there and find photos of many of the vehicles in our collection, multiple photos in some cases of interiors, exteriors, and motors in the case of these vehicles. So definitely a resource worth checking out. We also have something there in that portal that we call expert sets, where curators bring together a number of different objects in one set that are connected on a theme, and we have a couple of those, and maybe we can share the links at the end of this talk. But there's one on electric cars being marketed toward women, so we have not only the cars but also some brochures and advertisements of the time, and then some other pieces on electric related power, but certainly worth checking out. And I apologize, the other question was about,
is there a book? Has someone written a book on the history of electric vehicles?
Yes, there are a number of great books on the American automobile. I always recommend John Heitman, The Automobile in American Life, is a great place to start. There's an older book by John Flint called The Automobile Age, which published in the early 60s, so obviously it only goes through there, but everything up to that point, very well told. But typically those books have a section or two at the very beginning about electric cars, and then they go away and they never get talked about anymore. So we're starting just to see books come out now, taking in the second wave of electricity, where we are now. And there have been a couple of recent titles, and I apologize, I can't remember the name off the top of my head, but if you go to McFarland Publishing, it's a firm that specializes in automobile books. And maybe we'll get the link out and we can send this afterward or put it in the comments. But they've just published a book in the last couple of years, A History of Electric Automobiles, and it does go into experimental vehicles of the 1960s. The gas crisis of the 1970s brought out kind of a minor wave of electric vehicles, and then the more recent vehicles we've seen since the turn of the 21st century.
Jessica, if your listeners are also interested in technical, as an engineer direction, might have a technical interest in some specific topic, you can also go to the SAE.org website. SAE has a full collection of technical publications that go back almost 100 years. Their standards, their papers on new technology that have been published throughout the years. A great historical thread, if you will, and not only what's happening today, but you can go back in time to all of those standards and technical papers have been digitized now. They do have a great search engine built into their system. Another thing that you might be interested in is SAE has a technical committee called the Mobility History Committee. So these are made up of engineers, and again, they focus not necessarily on the literature or how the car was built or looks, or maybe some of the things that are more technical in nature, that how that specific battery worked, or that electronic system worked, or the engine operator, the ABS controller, and that sort of things. The SAE Mobility History Committee, they meet monthly. They welcome members to join, and you can connect to them through the SAE Detroit sections. Part of the things that we do at SAE Detroit is connect our engineering community together with like-minded folks, and they're a really great group of people. And old guys like me, but they're really smart. I should say guys and ladies that are very smart and have a passion for vehicles from an engineering sense too.
That's great. Thank you both.
Jessica, I'll jump in here just real quick. That book, I was trying to think of the title. The title is Electric and Hybrid Cars, A History. You would think I could remember something like that, but it's by Curtis Anderson and Judy Anderson, so fairly recently published in the second edition. And also I conflated two books. The Automobile Age book of the early 60s is by John Ray, and James Flink publishes The Automobile Age. So two great books on their own, well worth checking out.
Great, thanks. And thanks to the quick internet search, one of the things we're able to do in a digital format than we wouldn't otherwise. And I will just say on the subject of the digital collection, that's one of the things that I have enjoyed most digging into is, of course, the entire collection, but as we're in stay-at-home orders, the digital collection. And I thought I would just show one of my favorites, which again, I think speaks to the history of electric vehicles in America as we think about charging and range and batteries. This was surprising to me, which is, a map for motorists going back to 1923 of where you could charge your electric vehicle in New York. So today it might be on a smartphone, or your vehicle might know this information because it's programmed into it. But again, a fascinating example of the things that we can learn by taking a look at the past and thinking about how it leaps forward. So I want to bring us into maybe a new area of discussion, and there's a number of questions on this subject in the Q&A. Thank you again for chiming in the discussion there, which is around hybrids. We've talked exclusively about electric vehicles to date. And in the industry, we call these primarily BEVs, battery electric vehicles. But they're not the only type of electrified vehicle that's out there. There's plug-in hybrid electric vehicles, what we call PHEVs. There's hybrids that have more than one powertrain option. And so going back to one of my early comments around kind of the surprising things that we can find in this 100 years of history of EVs, hybrids actually are older than we realize too, right, Matt? So maybe talk to us about an unusual hybrid that you have in the collection at the Henry Ford.
Yeah, we have a hybrid car that, believe it or not, is over 100 years old now. It's our 1916 Woods dual power hybrid coupe. And here's a photo of it. And depending on your point of view, this is a car that either came way before its time or just a little bit after its time. Woods was a company that had started in the production of electric vehicles, and they realized by the mid-teens there that market was starting to evaporate. So they thought, rather than just go all in and building electric car or gasoline-powered cars, rather, what if we tried to combine the two technologies with a gasoline electric hybrid? And it works much the way a hybrid does today, in that you would use the electric motor to get up to speed, maybe 15 miles or so. Then the gasoline engine takes over, and indeed the gasoline engine can charge the electric motor. It's got regenerative braking, so when you're slowing down, the resistance of the generator will help slow you down and also help charge the batteries. The critical difference is with this, of course, the driver has to do all of that by hand. You have to consciously cut between the electric motor and the gasoline engine, whereas in a modern hybrid, of course, the computer does all of that for you. But it's a special vehicle. Unfortunately, you might imagine it was very expensive at the time because it was cutting edge technology for the mid-19 teens. Something like $2,600, I think, was the cost of this, which doesn't sound like much today, but that was a lot of money in 1916 and didn't help. Woods actually folded in 1918, so 2 years later.
And then we have kind of a more modern example of a hybrid we might think of today, right?
That's right. This is sort of the poster example, if you will, of a modern hybrid vehicle. This is a Toyota Prius. And this is actually a first generation Prius, the first version introduced in the United States. This model is from 2002. And it's not the hatchback that we all picture today when we think about the Prius and its configuration. But again, it's the same idea as the Woods dual power, trying to get the best of both worlds with a gasoline engine and an electric motor. Although in this case, as I say, it's all computerized, so the car does all of the hard work for you, shifting between the two. And the other big difference with this car is that it was expensive, again, with a cutting-edge technology. I think this retailed for about $20,000. But in the early 21st century, we had government tax credits to offset some of the costs to help encourage the sales of these vehicles. And we also had something Mark mentioned before, we now had eco-conscious, something that just didn't exist in the 19-teens. Now there were people who were interested in buying a Prius because of what it meant for the environment and because what it would tell other drivers of what they thought about the environment. We've always, I guess, been in that spot to some extent where our cars are kind of a projection of ourselves and of our attitudes. But the Prius allows us to tell other drivers something about our own values and what we place importance on.
That's great. Thanks, Matt. A couple of questions related to hybrids. Yes, the Woods dual power is on display at the museum, right? So people can come take a look at that one. And the Prius as well.
Absolutely, yes. Everything we've looked at today actually is on display, with the exception of the Edison prototype, which is actually on loan to the Automotive Hall of Fame, which is just across the parking lot from us there.
Across the way. That's great. Mark, one of the things that we talked about when we were getting into hybrids again are the standards that are involved in the power management and the automatic switching between systems. Is there anything that you've worked on with SAE in this area?
You mentioned that Prius, and that was a great example of an excellent engineering project. So with the SAE Detroit section, we had many events, and I actually got to meet the chief engineer who ran that project at one of those SAE events. The challenge there that I had a brief discussion with him. One of the challenges is that these standards didn't exist. I don't know how often the switch between battery mode and get the IC charged up, and how far, and what's the requirements there. Where do these all come from? So to develop standards, you need, first of all, some engineering requirements. And when they don't exist, you have to invent them yourself. Another thing, and SAE does that. We get the best minds together, gain consensus throughout the engineering industry, and we'll figure those things out. What's the optimum charge level of that battery, and those things around the connections and the charging systems, and et cetera. Part of the story also, though, you might be interested in, is that the state of California, for example, and the US EPA has defined regulations, and they do apply also to hybrids vehicles. So you think of clean air standards today for the internal combustion engines, but believe it or not, they've been extended. Those requirements coming from the government have been extended for hybrids and even for battery electric vehicles. How much charge are you taking out of the grid when you charge your battery electric vehicle? There's a regulation behind that, and the SA creates standards, and then the vehicle has to remember how much charge, so it can be reported out using one of these diagnostic tools.
And on that subject of charging and balancing, one of the things that we know in kind of the energy sector with the grid is that in many cases, the charge that you pull off the grid is priced accordingly depending on the time of day. In some cases, because it's related to cost of production, and in some cases because it's a demand management system. And there was a question in the Q&A around folks that have solar panels on their homes, or other potential energy sources, and can a vehicle interact with that potential power source. And that's actually there's a project right here in Detroit on the Wayne State campus. It was first built with Next Energy, but it's a small smart home, but it's very much focused on these questions of power management. And the home is wired for both DC and AC, which matters when it comes to both cars and our electronics today. But it supports the flow of electricity into a vehicle through the home, but vice versa. And there are some automakers and some companies thinking about how to actually use these electric vehicles or electrified vehicles as mobile power sources. And to the question about future technology, one of the other things that I've seen is companies working on sharing of a total charge across a fleet of vehicles. And so you can imagine certain circumstances where this absolutely would not work. You're driving alone on a rural road for 20 or 30 or 100 miles. There's nothing to share. But if these vehicles are operating in a city environment, or they're a small electrified vehicle operating, let's say, in a manufacturing floor, they actually could share and do power management back and forth, particularly when we get to some of the more advanced computing that happens in some of these vehicles today. So the source and the flow back and forth is something a lot of folks are looking at right now. There was another question in the chat. Has anyone ever owned or driven an EV? And I can say affirmatively in this case, yes. I actually don't own a car now. The only car that I've had in the past 10 years was a plug-in hybrid. So the question was around, kind of what's it like? And so this again was a plug-in hybrid, which meant that I could put gas in it or I could charge it. And this particular vehicle would operate on the battery charge for a certain number of miles, and then the internal combustion engine, the ICE engine, would kick in after that. And frankly, I loved that car. The challenges for me were where I live. I live in a multi-family housing situation. I don't have a garage. I don't have a driveway. And so, the idea of a woman in her garage charging her vehicle, I was halfway there. I didn't have the garage part. And so I would have to charge at work, or my favorite was actually charging at the airport. When I would travel here in Detroit, Metro Airport has some very primo parking spots for electric vehicles. And so I could always count not on being able to charge, but getting a great parking spot as well. And then what I loved about that vehicle, frankly, was it was super zippy. And this is one of the unknown perks about electric vehicles, if you've never had the chance to drive one, is there's no lag in the design. When your foot goes down, that vehicle goes. And I'm not advocating breaking any motor vehicle rules here, but it does have a pep and a pickup that an equally sized sedan or hatchback might not have. So I appreciate that question very much, because we know even among people in the industry in Michigan around cars all the time, a lot of people actually haven't had a chance to drive an EV. And it is one of the things that we know in the industry is really important in helping people understand how they can fit into their daily lives. There's some industry research out that shows most of us still think electric vehicles are good for someone else. We want to stick with what we have now, and I think it's that exposure that's really going to help tip the conversation forward.
Part of the conversation also, Jessica, I think, circles back to charging. how big is the battery? What's the range? How much energy can you store in that to propel your motion? If you think to a semi-truck, something heading down the interstate highway, it would seem, you know, that once you get up to speed, you don't need that much energy. But getting that vehicle and that mass moving, that really takes a lot of energy. And how do you keep that going? And then next step is when you run out of juice, how long does it take to charge up? You want to, can you go roll into a truck stop and hook up and get a fast charge in 20 minutes while you go get a hamburger? Probably not, because the amount of energy, and in fact, you bring down the grid everywhere that you stop to charge that big semi up, right? So those are things that, so it's just not a vehicle or a battery-centric solution. It's a community, it's a system-centric solution, and that's going to take years and years and years. Mary Barra said something about that recently. It's going to take years and years to build up that infrastructure. Instead of running into the Conoco station and in 2 minutes topping up your tank, you want to stay there for an hour and get charged, or you get it charged at home and you don't care about it. You still need to get that energy from someplace. Those things are, those are technical and business solutions that are still evolving.
Absolutely. And, this question again of how and where most of us will use these vehicles. If it's in a lightweight delivery truck, for instance, that company probably knows how many vehicle miles that truck will go in a day. If you do a personal travel audit, you can probably know on a day-to-day basis what your commute to work or school might be. I think the lingering question is on road trips, and will I feel confident running a whole bunch of errands? There's a question here too around charging infrastructure, not at work and not at home. And yes, that's something we're seeing a lot of too, is stores actually, not for the big semi-truck mark that'll bring down the grid, but the little EV like I had, where I could do maybe fast charging, where it doesn't top up the battery completely, but it gets me enough juice to get where I'm going. And these stores are actually thinking of it as a benefit. Think of, if you're a big retailer, if someone has 20 or 30 minutes to kill while they're charging their vehicle, the retailer would say, what better way than do that and come into my store and spend some more money while you're here in my parking lot. Other companies are looking at serving ads as a way to kind of offset access to the infrastructure. And the reality is most of the EVs today, they have one of those chargers that you see with they have the plug for the chargers that you start to see being installed, but most of them still have that extension cord that you can plug it into, any outlet that you happen to find. So it might not be ideal, but truly getting stuck is something, I think it's a fear until you try it. I never got stuck. Of course, I had a little gas in the tank too.
Jessica, there's another, you brought up education, consumer education. Maybe before we wrap up, I wanted to also throw out there that the resources that are available, if you're in the K through 12 education, or even in collegiate area, the SAE has plenty of resources that for many of it for free, that can be support teachers, science teachers that are interested in showing that their students what the future of mobility would be, including electric vehicles. So you've got background in that. I know the Henry Ford does too. I think it would be really great to share some of those things with your audience here too. We've got a few minutes.
That's great. Absolutely. Yeah. So we have actually less than 10 minutes left, which we've got so many questions here. We'll have to figure out how to answer them or tackle them in some sort of follow-up. But I do, to kind of round out the discussion here, I want to take us to a place where electrified vehicles are just starting to go now, which is in the realm of self-driving vehicles. And the two are not necessarily linked, except maybe they are. So to kind of bridge into this discussion about self-driving vehicles, I mentioned one of my favorite things has been poking around on the digital archives. I had to share this with everybody first. This has nothing to do with electrification, I'm sorry. But this is an early example of cruise control. So this, Matt, is from 1950, right? And it's a ratchet system that you could actually mount next to your gas pedal to depress the pedal, and the catch would hold, and it would hold down the gas pedal. So you could cruise comfortably in your vehicle as you're going down the road, right?
Yeah, sketchy is the only accurate way to describe this device. But yes, you'd install it yourself. It would lock down your gas pedal for you, and it was interlocked with the brake. So if you hit the brake, it would release the gas
Yes.
pedal. But obviously, it didn't adjust or compensate for hills like a modern cruise control unit. So it would be great, I guess, if you're driving over a long, level, flat stretch somewhere. But otherwise, no. But I think it just goes to the point that we've been trying to simplify the work of driving and moving in a direction toward autonomous vehicles for perhaps a lot longer than we might initially think.
Exactly. So I know that there's an example in the collection at the Henry Ford around the future of autonomy. So Matt, I'll bring that up. Can you talk about the GM first generation self-driving vehicle?
Yeah, this is one of the newest vehicles in our collection, and it does point the way toward what may be our future. This is a 2016 GM first generation self-driving test vehicle. This is one of the first vehicles they developed in concert with Cruise Automation. And these vehicles were tested out on public streets in San Francisco, California, and Scottsdale, Arizona, in the Phoenix metro. And the vehicles were driven, well, I say driven, but they were accompanied by engineers and folks who would be in the seat there. There were controls for the driver. There was an emergency button, so a driver could step in and take over if necessary. But for the most part, that wasn't necessary. These vehicles ran very well. They weren't involved in any serious incidents. And what really draws me to this vehicle is just how clearly sort of prototypical or experimental it is. I mean, you look at the way they just sawed out holes in the bumper there to put the mounts for the radar units up front, and then the LiDAR units on the top, and an array of cameras. And yes, AV vehicles are almost by default electric vehicles. The sort of electricity you need to operate the computers and the systems, it just dwarfs the amount you need to actually propel the car. In some ways, driving the car is the easy part. So this is an interesting case study, and it will be fascinating to see where we go. Having said that, and Mark, I'm sure will say more about this, I remember 5 years ago, it seemed like we were all going to have self-driving cars in the garage by 2020, 2021. I think manufacturers have kind of backed off a little bit on that as we realize some of the complexities involved. And they're not just technological issues, that we have legal issues to worry about. We have psychological issues to worry about. How much faith are we willing to put into these vehicles?
SA has worked together with industry and with the government, with NHTSA, to develop the 5 levels of autonomous driving, those categories. So now we know when you're talking about hands-off but attended, or full autonomous, where you can sleep in the back seat, level 1 through 5. It's all part of an SA standard, J3016. And that took a few years to develop, and we're continuing to develop further standards around that area. And here you see the wires dangling. Those are probably wires that go to the sensors on the wheels there. There's new network communication protocols. This vehicle uses Ethernet to share high-speed data between the different control units within the vehicle. SA is working on standards for Ethernet communications in the vehicle. It's not the same as the standards, and the requirements are not the same as you would imagine as Ethernet in your office building, or Wi-Fi at home. Very, very important to get it right and to have a standard that all the manufacturers, the vendors, and suppliers can follow. If you're making these sensors or connecting up the LiDAR units and integrating it into the entire vehicle. Just like the early days of SAE, those fasteners and lug nuts that we talked about at the beginning. And SAE is very involved in this. And then the power generation here, it's amazing how much power.
Yeah, and SAE really has become synonymous with the different standards around the future of autonomy. I mean, it really is the default definition for how this technology has evolved. And, one of the things that I think is really fascinating about the examples here today of vehicles that are prototypes, and then the role of the standards is many times the technology kind of gets out there first, and then it takes kind of a collective recognition, including among the engineers who've designed the technology, that we need to kind of put some standards and regulations in place. And we've seen that kind of starting and stopping again over time. And I think what's fascinating about this question of, is an autonomous or self-driving vehicle the ultimate electric vehicle, is in many ways it breaks the narrative, which is so much of what we've talked about today is focus of electricity as the power source, and autonomy really says it doesn't matter what the power source is anymore. It's about the movement itself. And so I know, for many here in the region, that's an area that we work on as well. But I do want to recognize that we're at time, which again is shocking given the number of things that we still hoped to be able to share with you. So I would encourage everyone to continue to check out the resources, both on the SAE website, the SAE Detroit section specifically, if you're in the industry, and then all of the resources at the Henry Ford as well. And I think what's really, frankly, great about this discussion is it reunites us all in this initial vision that was shared by, Thomas Edison and Henry Ford, Riker, and these other early engineers. And so thank you for really everybody here for being part of that. And as I mentioned at Michigan Mobility Institute, we have this concept of the mobility engineer, and it's someone whose technical and business skills, they cross specific domains within engineering, and they incorporate an understanding of both design and history and the ecosystem that these vehicles will operate in. So we're really committed to continuing to partner with organizations like both of yours to make sure that both working professionals can keep up with these changes, as well as younger kids in the next generation that we want to be excited about these vehicles and this design can stay connected as well. I know there were some questions about resources for young folks as well. It's an area that we're working on at the Michigan Mobility Institute as well. So I want to thank both SAE Detroit section and the Henry Ford for being great partners of Michigan Mobility Institute. This programming and these conversations are possible only through that engagement. So from the bottom of my heart, thank you. And I'm really excited to continue to expand the innovation curriculum and access to the Henry Ford's artifacts. And so one of the things that I will be working on speaks to the next generation of engineers. And so we are working now on taking some of the innovation curriculum that the Henry Ford has developed and extending it to a group of summer interns from the city of Detroit. And so as we think about continuing to get excitement in our own communities and raise others up with great jobs, think about how you can get involved with this too and build bridges across your areas of expertise. And so with that, I'll say thank you again. A recording of this discussion will be available through our various networks, but will be posted probably first on the Henry Ford's website on the YouTube channel, but look for it on Facebook as well. So thank you all and have a great afternoon.
Thank you.
Thank you.